making their way around the world. So each dot there is a new insect that is travelling to a new country, not the same one over and over again. And that rate has been increasing since the 80s. And as mentioned, my background, or where I primarily work, is in the biosecurity area, so trying to prevent these pests established in the first place. And one of the colleagues I work with at Sion, Eki Brokerhoff, has, with others, worked out that we've potentially averted $100 million to $1 billion in costs by eradicating a few of the pests that have arrived on our doorsteps. So, moving on to brown marmorated stink bug. In case you hadn't seen it before, this is the damage that it can cause. Starting at the top right there, we have an apple. You get that little dimpling going, and then on the sunny side, you get a bit of a red hue showing where the insect is feeding as that fruit is developing. So it's going to be early on when it's quite a small fruit. And then on to kiwi fruit. Enjoys those as well, as everyone does. And the cherries, beautiful. So you got some adults there having a wee feed on some cherries. And it got to the point in the US where it wasn't even worth harvesting peaches, even for juicing, because of the damage that was done. Now, it's not only your traditional fruit they go for, they do enjoy corn. So one of the colleagues I work with right now, he's in Italy at the minute, and he was travelling to a place yesterday to collect a whole lot of brown marmorated stink bugs from a cornfield. And if you think of New Zealand, that's a great little patchwork of, we have corn, we have some fruits, all different varieties of things to eat, and brown marmorated stink bug is going to love it here. So when it comes to a response, we're all going to have to work together with quite different industries to try and manage or eradicate it primarily. So I've also put a picture. You can see a nymph there. That's one of the life stages of the insect. It's with that blue background, and then a whole lot of eggs where the individuals have just hatched. So not only plant food, but others in the room have been trying to think of how we're going to manage or eradicate this pest if it turns up. And what New Zealand has done as a world first is they have the approval to use a biological control agent to help support the eradication of brown marmorated stink bug. So we have the bit of paper is sitting in someone's desk, and if brown marmorated turns up, that bit of paper can come out and be used, and then we can release this egg parasitoid. So a lot of work has gone into this. So with scientists, and myself included, hunting on the landscape, looking for the species of bugs we have in New Zealand to see if there are any non-target effects. And then also importing these Trisulcus into containment and running a whole lot of trials looking at, are they going to primarily go for brown marmorated stink bug eggs, or some of the species we have in New Zealand, or a little bit of both. And there's enough evidence to show that this would be good to use in eradication, along with a whole lot of other tools. Now, no one else has managed to eradicate brown marmorated around the world, so we've been lucky being so far away that we've managed to hold it at bay despite having a lot of detections at the border or slightly just after the border. And something we're looking into at the moment is, can we use sterile insects to eradicate brown marmorated stink bug? So sterile insect technique is used in many countries, quite a few countries around the world, for managing fruit flies, different fruit flies, so like your Queensland fruit fly, for example. It was used in New Zealand for the eradication of painted apple moth, one of the tools that was used during that eradication, along with a biopesticide and trapping. So this is pretty new. No one's looked at trying to irradiate a pentatomid and then see if it's sterile. So the idea with the technique is that you have a large population, usually something you've reared in captivity, of the pest. You irradiate it with radiation, and at a particular dose they become sterile. Now, you release those insects, usually one sex, and then they go out and hunt down those last females in the population. Normally, males are only released, but with some of the tools, you have to release both species just because it's hard to separate the two. And so what we're showing at the minute is that we can irradiate the insect, and you see on the graph there's a little box on that black line, And at a reasonably low dose, when you look at a whole range of insects, we can have a very low number of individuals that come through at the end. Now there's little benefit from irradiating at a higher dose there, so you can see the dose along the x-axis, because at the same time as you're irradiating and making them sterile, you're also making them less fit, so they start getting to the point where they have trouble standing and they've got all these twitches going on, so you'll be releasing an insect that isn't particularly fit for the environment. So that is something we're looking into at the moment. I guess the big issue for us though is going to be, are we going to mass rear the insect in New Zealand? And currently there is no mass rearing technique, so what is required is a whole lot of people feeding these insects with fresh produce of a variety of ranges of beans and nuts and all the sort of thing. Or is it something we can look into? Can we import from overseas and irradiate overseas insects for release? But of course that comes with a whole lot of other questions around associated organisms and the like. So we have a PhD or candidate in Italy, and he's going to be working on that side of things. So if you haven't overwintered these populations, what they'll do is they'll aggregate and overwinter together. So that's the best time to collect a whole bunch. And he's going to look into what happens during that winter timing. Do they evacuate any of the pathogens they might be carrying? And then when they get irradiated as well, are there any pathogens left? So those will be questions that will be asked for us if we head down that route. Now, one of the exciting things, working with all these people overseas, is the science of biotremology. So we've known for a long time insects use sound to communicate. You've heard cicadas, crickets and the like. And now there's some groups around the world, and we'll stick with Italy, and they're looking into the use of sound for pest management. So that's the vibrational communication. So as I said, a number of species use it, and it's species specific. So you think of sex pheromones, they're species specific. You put out a pheromone, you generally get a moth turning up in the trap. And the idea is the same here. You can put out the sound and you'll get an insect turning up into a trap. Or you could put out a whole lot of sound and disrupt their ability to find each other. And this is quite fortunate. We've hooked up with these people because there are the pests that are moving around the world, so your brown marmorated stink bugs, your other bugs, don't go into a trap as easily as, say, moths to a pheromone. So they have an aggregation pheromone, so that brings a whole lot of bugs into an area. But until you get a really high density, they won't get caught in that little trap, which is much easier for any of the trappers who are out checking these traps. So I've got a couple of video recordings of the people who are leading the work. So first, Sabina will talk to you. She was in our lab the summer just gone, and looking at coming out again. She was working with tomato potato psyllid. And if you want to hear what that sounds like, you're welcome to come visit me later on in the plant and food stand at the back, and I can talk to you a bit more about this and play you some sounds. But she's going to tell you initially of how you record the sound from the insect, and then from there, once you record it, how you remaster it, redigitize it, to be able to play that outside.
Hello, my name is Sabina Bosani. I'm a PhD student in Italy, and I'm studying the vibrational communication of the middle spittlebug. I'm using special equipment for studying this channel of communication. I will use a laser Doppler vibrometer, this kind of instrument, that are able to measure with a laser beam the vibration that are emitted by an insect, in our case, through the substrate where he lives, in this case the leaves of the plants. And here you can see also a mini shaker that is an instrument that is connected to a MP3 player or to a laptop that permits us to transmit a stimulus through the leaf of the plant, and we use two lasers to follow the movement of the insect and to also to see if there are differences in the vibration emitted, and
So we'll pause it there. She goes on for a bit. So, so we have to have specialised equipment to record what that insect, what that sound is that they're making. So using a laser pointed at a reflective surface, so we get that vibration going back and forth. And then we have to somehow recreate that sound and play it through the mini shaker, which again I have over at the stand, you can see later on. So she's a PhD student working on meadow spittlebug, but was here working on TPP and looking at coming back this summer. Now Valerio Mazzoni, so he's also at the Fondazione Edmund Mark, so that's the institute we're working with in the Trentino region, beautiful region. He's the research leader, so he's going to tell us a little bit about how they're using the mini shaker in the field. So they've put these in the vineyard. They've got a research vineyard, about 2 to 3 hectares. And they've got the mini shakers set up in there, playing the sound down the wires, a bit like a guitar string, and disrupting the ability of a plant hopper to find each other.
Hey, this is a vibrational vineyard, and this is the first vibrational vineyard in the world. We are trying to take care of grapevines using physical methods instead of chemicals. In this case, we are trying to control leaf hoppers. There is a bad leaf hoppers here in Italy, Scaphoideus titanus, which is a vector of a bad disease. And what we are trying to do is to substitute, to replace chemicals, insecticides, basically, with physicals that are vibrations. So, now, okay, here we have a sample of a mini shaker. A mini shaker is an emitter of vibrations. As you can see here, this is a very tiny device, but rather powerful. It can send vibrations through all this row for 50 meters. And then it's very a good performance for us because it takes a few of these instruments to cover long rows and so having spare money. So what are these vibrations? These are specific vibrations that cover the exact frequency that Scaphoideus titanus, the pest we are fighting, uses for mating communication. In this way, mating communication is disrupted. This is a mating disruption method with physicals.
Yeah, so this technology, it's very early on. As he said, that's the first field setup of that. It's going to be quite interesting when we look at all these other pests. How are we going to maintain our access to markets and the like overseas, and not have to go to using insecticides as many other countries have to do with the likes of brown marmorated turning up and spotted winged Drosophila and the like. Now the mating call of brown marmorated stinkbug, it's pretty deep. So the female's calling and the male sort of stands, listens, runs, listens, runs, listens. And we'll let it play again, sounds good. Just imagine that at a nightclub, So we're thinking of this going, well, for surveillance, this would be great. If we can, I'll stop there now. If we can have this aggregation pheromone out there, bring all the bugs into an area, how can we get them to that trap to increase the sensitivity of our surveillance? Or, if worst case, it became established, can we reduce their ability to find each other and have offspring? Now, what else we're looking at as well, as other countries are, is the use of lure and kill. So instead of spraying the crops with an insecticide, and this beast is pretty tough. You spray with an insecticide, it plays dead, brings its legs in, waits for you to walk away, and gets up and continues on its way. Very hard thing to kill. So we have here ghost nets, or Nazguls, as someone's called them. And what we have there is an insecticide-treated net. And at the top of that is the aggregation pheromone. And so that's bringing all the bugs. This is the nymphs, the males, the females, all life stages. They're walking or flying to the area and eventually alighting upon that insecticide-treated net. and they stay on there long enough, they get a lethal dose and die. Okay. So we've just been starting to get a feeling for how it could be used, perhaps in New Zealand in a response, by avoiding spraying the crop, and what sort of density of these will we need. So at the moment it's just research. We have the little collector at the bottom, just to get an idea of what proportion of that population are we taking out. And there's the back of the PhD student as well, Gerardo. He's great, loves his cars, and hopefully we'll get him out here at some stage and he'll be able to talk to some of you in a year or so. Now, just moving on to another pest. You may have heard of Queensland Fruit Fly. So we're also working on different tools for that as well. Now, I was fortunate enough to be in a meeting where we're looking at combining lure and kill. So here we have a lure. This one's called Splat. It's by an American company. Consistency of toothpaste, and it has a male attractant in there. So the males are highly attracted to this lure. They feed on it, they fight over it, and then they take in poison and they die. And the idea is, can you use sterile insects? So these are sterile males. Can you release them at the same time as killing a whole lot of males? And initially the first thought is no. You don't want to be rearing all these insects, irradiating them, which is really costly, and then killing them all. But some scientists now have found that if you can pre-feed them with some of these chemicals, you actually make the insect you release non-sensitive to it or non-responsive to the lure, which increases your ability to reduce that population. And then spotted-winged Drosophila, same sort of thing. So we're working with a lot of overseas researchers who are trying to combine sterile insect techniques. So Drosophila, those little vinegar flies, and you can see their little characteristic spots on the wings of the males. They are a pest of a lot of these fruit fly rearing facilities, so this is the perfect organism to rear up in large numbers, eradicate and release. And looking at combining that with biological control agents to try and manage this pest. So we're thinking, how can we use this in New Zealand? Could we again look at sterile insect technique or something like that to knock these populations out? Because this is just going to go through the roof. This breeds like crazy. So that was a couple of pests we're working on, and I thought we'd switch now to a pest that a few of you are familiar with and we have in New Zealand. So we're using sterile insect technique with other current tools and a little pilot program against codling moth. So our goal is to have low residue, pest-free and the like. And why we want to do this is because we want to keep maintaining access to those very lucrative markets overseas. So how it's working is that there is a codling moth facility based in Canada, and of course Canada winter is our summer, so that's when we need the codling moth. So it works well for them. They get to have some sales during the winter. At the minute they're not charging us too much because they just want to get the idea up. And what they can do is send us codling moths. It takes about 35 hours from them sending it to them being the codling moths being released in the Hawke's Bay. And we're running at about 120,000 per week at the minute in the central Hawke's Bay and Heretaunga Plains. So, for this, we need to get the approvals to release these insects, of course, and we have that window of release. So we'll show you some results and you can see how it's coming along. So these are the sites, if any of you are familiar with them. So you've got the name of the orchard and the size in hectares. Just by Onga Onga. And initially releases were made by bicycle. So I know Dave's in the audience. I saw pictures of him biking around the orchard releasing those, but that's quite slow. It's very healthy for the person doing the biking, but it's quite a long time taken to release those insects. So then the group moved on to using drones, UAVs, trying to get these insects out in the environment quicker, and also in a nice smooth pattern, so you got that nice overflooding ratio rather than having little clumps here and there. So historically most of the work has been done with a fixed wing drone, and that's so over a size of about 100 hectares. That will be 10 minutes to treat that area. We'll release a whole lot of sterile male moths in that area, 22,000 odd. And then this year moved on to the hexacopter, so it's a little bit slower, but the hexacopter can fly a lot lower to the ground, so then you're not getting a whole lot of spray drift, or not spray drift, but moth drift getting blown out of the orchard. So that's what it looks like. So this is from the fixed wing. Just took a few videos just trying to calibrate the release rate. So we're just using the wind, or the force of the wind at the front end of the container to blow the insects out. So the insects are kept pretty chilled, so they're immobile and staying reasonably fit. And then as they're falling down, they're warming up and flying through the environment. And what we saw, so this started around 2013-14. So that's your baseline year for that year in the light blue. And we had quite a few orchards, so non-SIT ones, so just use the conventional approaches they were using in those orchards. And then ones where SIT was put on top of that. And you'll see there were quite good reductions in those SIT orchards. Now if we look at what that looks like spatially, so this is what the orchard, this is one of the orchards here. We had quite a few counts, let's say 35 moths in 100 hectares in the year. So still reasonably low numbers. And then with SITs, this is now through to 2017-18, we've got it to a point where there's just the one moth caught in that area over the whole season. Just really great numbers, but there's still that one there, and where the heck they're coming from. You can see that's right on the edge of the crop there. We really still want to knock that down so we can get down to that zero, but one is still very good and will help for market access. So I thought I'd better wind up. I don't know how I'm doing for time, but we all have to keep working on these novelties. So for us it's pest management, for you it's different ways of growing crops or new crops. And it will help us for the pests at least manage these pests for which we have few or no tools currently. And we need to keep thinking of the new tools because we are losing, we do lose some of the pesticides through reassessments and the like. So we need to have something else in the pocket to be able to use. And we've also got, these high-end markets, we've got a lot of the consumers saying they want the low residue, what have you done to your fruit? What's the story? Tell us your story. So we need to keep being novel. And we may be able to get some of these new pests. So you have Drosophila, spotted-winged Drosophila. You have the spotted lanternfly, really cool-looking insect. It's a plant hopper, but pretty bad for sooty mould, and we have examples of that over at the stand. And if we develop some of these, and some of you may notice, passion vine hopper, so that's not actually it's already here, but if we can develop some of those tools for the pests we have in mind that aren't here yet, we may be able to take those and actually manage the pests we have in a new way. Then right at the end there we've got Vibrational bug, so it loves cruciferous vegetables. Heck of a beast. Anyway, thank you very much for your time.
Well, we do actually have just one question that perhaps you might turn your skills to. And is SIT able to be used by growers to manage a sudden increase of pest pressure in the same way that you would apply a pesticide, or is this a regular sector-wide application?
All right. Yes. So to manage the pest, you really want to do it over a large area. So you want to be working with your neighbours and the different crops. So we're involved in a project on Queensland Fruit Fly management using sterile insect technique in Australia. And of course, if they can manage their pests there, there's less likelihood of us getting it in New Zealand. And the idea is that once you have a catch in a trap that reaches a threshold, an order could be put into the fruit fly facility, and they will send you out a number of flies that are required to be released to manage that area. And the idea is to have a whole lot of crop scouts or people working together in that area so that you have a coordinated response rather than just doing it on farm and then having a whole lot of flies turning up the next day from the neighbour. But if you have the insects available, you can use it a little bit like that. It just takes a while to rear some insects through. But of course, SIT hasn't been developed for many of the pests that are out there, so it comes down to what the pest is and whether you have availability to use them.
Well, thank you, Lloyd, for the insight into the very important and crucial work that you do. I have to say that the stink bug mating call sounds like something Pink Floyd would have done in 1973, only longer. But do enjoy your tractor. Ladies and gentlemen, Dr. Lloyd Stringer.